Hi, my name is Jessica, and today I will be talking about the three foundational principles of transfers, which are pelvic tilt, tibial translation, and applying pressure through the foot. Let's go ahead and get started with pelvic tilt. In any given transfer, the pelvis is extremely crucial as it determines whether or not someone can stand. It also helps with how we manipulate our center of gravity so that we can prepare to stand or sit back down. And the first type of tilt that I'm going to talk about is anterior pelvic tilt, which is where the pelvis tilts forward at the acetabulo-femoral joint, and I will go ahead and demonstrate that. So anterior pelvic tilt would be like this. And as you can see, it makes my lower back curve inwards a bit. And then as I prepare to stand, it's going to help me distribute my weight from the spine to my lower limbs. So like this. And then that helps me stand. And then the negative movement would be posterior pelvic tilt, which is where the pelvis tilts backward at the acetabulo-femoral joint, so like this. And then it also changes my posture as my lower back is curved a bit outwards. And then the pressure is more on my spine, so there's no weight distribution from my spine to my lower limbs. So when I try to stand, it's much more difficult to stand because now the pressure is more up here rather than an equal distribution downwards to my lower limbs. I can only stand if I use the chair to help. So with posterior pelvic tilt, it makes it difficult to stand up, which is why the pelvis is extremely important. The client factor that I will be focusing on for the impairment question is body function, and I specifically am going to focus on the impairment of joint stability. So the client in this case, they have joint instability. So that means that their bones are not aligned properly and that their joint stability is impaired. So that affects how they move and how they sit and stand and the transfers. So in that case, anterior pelvic tilt would help them, help them have some support in their spine so that the weight moves down to their lower limbs, which would help them try to stand even though they have a joint instability. And posterior pelvic tilt would make it really hard for them to even attempt standing up because once again the pressure is placed on the spine and there's no weight distribution from the spine to their lower limbs, which would make it hard to stand, and in their case it might also make it painful to stand since they have joint instability. The next principle that we are going to talk about is applying pressure through the foot when standing up. And what this principle states is that in order for us to move our body upwards to stand, we have to apply a pressure towards the ground through our foot. And there's two ways in which that could take place. The first is when you apply pressure through the midfoot. And what happens in this movement is that the force that you put into the ground is applied through the middle of your foot when you initiate standing. And then what happens in that movement is that our feet are our base of support, and then when we put pressure through the midfoot, It enables us to stand because our center of gravity is right over our base of support, which is our feet, and that helps us stand, and it also gives us stability as we do that. And I'm going to demonstrate applying pressure through the midfoot. Okay, so as you can see, my feet are flat on the ground, and I'm going to be applying pressure through the middle region, so right here. And I'm going to stand up. And I was able to stand up. And I was also able to maintain my balance as the pressure was applied through the middle of my foot, and that helped me keep my center of gravity over my base of support in that area. And going back to our client who has joint instability, in that case, applying pressure through the midfoot would help them stand up or try to stand up, because it would help them keep their center of gravity over their base of support, and that would help them maintain their stability and balance, and it would prevent them from falling. And falling would happen if your center of gravity goes outside of your base of support. And since the client would apply pressure through their midfoot, it would help them try to stand while maintaining their balance. And the negative movement for applying pressure is applying pressure through the ball of your foot. And what happens is the force is applied through the ball of your foot, which is like the top part. And then what that movement does is it puts your center of gravity outside of your base of support, and it makes it hard to stand. And it also makes you like lose your balance, and then you end up falling. And I'm going to go ahead and demonstrate that. So I'm going to apply the pressure through the ball of my foot, which is the top part. And I'm not able to stand because the pressure is applied through the top part of my foot. And if I use the chair, I can, but it makes me like lose my balance. And once again, going back to our client who has joint instability, applying pressure through the ball of their foot would affect them, as it would make it really hard for them to stand, and they have a higher chance of falling because what happens is their center of gravity goes outside of their base of support, since the force isn't being applied through the middle of their foot, but rather the ball of their foot. The last principle that we are going to be talking about is tibial translation, and this principle states that in order for us to initiate standing up, the tibia shortens the angle between the tibia and the foot by bending forward at the talocrural joint. And the main movement, what it does is it enables us to stand up, as that short angle between the tibia and the foot kind of stabilizes our feet, and that helps us stand up. And I'm going to demonstrate that. And then I am going to initiate standing up with a tibial translation. And then what happens is the angle between my foot and my tibia is going to shorten, which helps stabilize the area so that I can move up. So like that. And then going back to our client who has joint instability, with tibial translation, they will have an easier time standing up, as that angle between the tibia and the foot would help them keep that area stable so that they can stand up. And then the negative movement of this principle would be the angle between the tibia and the foot being lengthened, and what that movement does is it makes it hard to stand up because that angle, it tends to make our feet feel unstable, which interferes with how we balance and how we stand, and I'm going to demonstrate that. So in this case, the angle between my tibia and my foot, it's longer than before. And so when I try to stand, I can't. I would have to use the chair. Even using the chair as a support, it makes it hard to stand because of that lack of stability in my feet, because of that longer angle. And then in relation to our client, the negative movement of tibial translation would impede their way of standing up, as that lengthened angle would make their feet feel unstable, and it would make it hard to distribute the weight to their lower limbs because of that lack of stability.